Sorry. So this is the shape. I just to summarize what we just did. This is the class. We're trying to introduce polymorphism using these classes. Now, polymorphism means many forms. So what are the things that are taking many forms? Well, basically, this is the get area that we need to focus on. This is the one that is taking many forms, and I'm going to show how it is going to be taking many forms. But now it's not really that clear. But what I did, I just created this shape. This was private member, and we just used a string, and then we created these getters and setters, and we also added these optional constructors, but just to have something to initialize it with, and then we tried it like that. The area we chose return 0 because we need to return something, and for a shape there's no specific formula for like a generic shape. If it was a specific one, like a square, rectangle, triangle, whatever, circle, I know there's a formula for that. But if just you tell me shape, I don't know what's the area of a shape. So now that's why I just put it like a 0. And then I just added this get area just to have something different from just the one that is generated automatically by NetBeans. Just, I don't know, just to make a change. Now I need to add the other classes. And this one is going to be, let's say, the triangle. And in the triangle, I need to extend shape. Now, when doing so, I'm just inheriting now from the triangle, which means I'm inheriting the get shape, all the public, all the non-private ones, right? By doing this, I'm saying that I'm inheriting everything that is non-private from shape, which means if I go to the main and instead of doing the shape S, I make it triangle. Let's say call it T. Of course, I don't have a constructor that takes an argument, but I do have one that takes nothing. Now, if I make this T, what should I see? Exactly. Shape, white, area, 0. Because it was the shape that was coming. This thing, when I did this is coming from, I have a toString that is coming from shape. It's not coming from object anymore because I'm inheriting, it was overridden in the class shape. And I also have get area that is coming from shape as well. Notice that nothing is bold here, but it's because I have nothing that was defined inside my class. If I define a method inside triangle, now I can do that, then I will be able to see it as bold. But because I didn't, now it's not showing anything. That's why I have nothing. This class is empty, and that's true. It's empty. I did not do anything yet. Now I'm going to do things. Let me just, for example, start with the constructor. I just would like to initialize a constructor that is going to be calling this one. Now, I'm going to now have a new triangle that takes a color, and that color I'm going to send into the superclass, which is the shape, to initialize the color. And now, if I'd like also to have the one that does not initialize anything, just the one that uses this, you just put nothing, means it's going to call the one with no arguments. Because if I just don't do this, even that one, that seems like a useless thing to do. Why would I just do something like that? Well, notice that because I created this constructor, the one that takes no argument is no more available. Because it was given to me by default when I did not have any constructors, but when I defined one, the other one was not available anymore. So if I still want to do something like this, then I have to do something like this, which seems like useless, but actually it serves a purpose. Yes, you had a question.
I was going to say there is also variables to be declared.
Variables, yes, of course, we're coming to that. Yes.
You're not able to put them inside of the constructor, right?
No, because if I put some variables, I declare them inside the constructor, they're only known inside the block they are declared in. And I want these members, these instance variables, to be available for the whole class. So I need to declare them inside the blocks of the class. Yes? It depends on when you call it. Now this one, for example, for the no argument constructor. So this is the one that is going to be called. But if I do something like this, now this is going to be calling the constructor, this one, and this one is going to be calling the constructor of the shape, that one. Now, that's the idea. If I run it now, I'm going to see red. Yes. And of course you need that, because you don't have access to color. It comes from the superclass. So you take the information in triangle and then you send it to your superclass to do the job of the initialization. Exactly, because it's private. So let's just declare those instance variables like this base and height. I'm going to make everything to be double. Or it could be int, but just make it double too. Double base and double height. I did not put them private because I'm lazy typing. I just would like to generate getters and setters and encapsulate the fields. This is going to help me get everything made as private. So I'm going to insert. Remember, by just clicking on this encapsulate fields, these are going to become private. So that's why this becomes private. And they need to be private because there's a minus before them. That means private. The plus, public. So now I have these things, and now let's just start with something else. Well, first of all, if I'd like to have this constructor that initializes only the color, that's kind of cheap. But what about the one that initializes? I would like to initialize the color. Actually, I'm going to remove this one because I'd like to initialize everything in one line. Why just the color? So I'm going to generate a constructor that is going to initialize the color, the base, and height. And this means that I have this base and height, and then the color as well. The color is going to be sent to the superclass to be initialized, and these ones I'm going to initialize them locally inside this thing. Now, it's very important to understand whatever I call the superclass's constructor or any constructor within another constructor, this has to be the first statement, because if I put it as the second or the last, logically it doesn't make a difference. You know, if you think about it, the color, you put it first into the superclass or you put it last into the superclass. At the end of the constructor, the color is going to be set. However, it's not how it works. When you call a superclass constructor, the superclass constructor is the first one to be called, so you have to put it at first. So this is not going to work unless this is the first statement inside the constructor. This also works with this. Okay, if you call this, because I'm calling this constructor that takes no argument. Basically, I'm just calling this one, which makes the color to be white, and then I'm doing this. Well, but the idea is that if I do this, it has to be the first one, because if it's not, again, that's the same problem that I'm going to be having. It's going to be like not accepting to be something else than up. So my point is, when you use this or super to call a constructor, this has to be the first statement in your constructor. Yes?
Can I say this color,
This dot there's no color. If you say this dot, you're looking for variables. So there's no color here because the color is on not this, on the super one. So if you do super dot color, for example, you don't see color because it's private, so you cannot see it. And if you, even if you think, okay, you know, I'm smart, I know that there's a variable called color, I'm just going to put it there. Well, NetBeans is going to tell you color has private access. You cannot use it like that. So you can do that. Yes. No, it doesn't. You mean you're talking about this thing? I did not create color. As you can see, it says that these are the only two variables that are available. These are the only two available variables. I added the color because this triangle is inheriting from shape, and shape has color, So if I'd like to store some information into that variable color from shape, I need to be able to capture it. Either you do this or use the setter. The other thing that I could have done is that set color. But this is not something that is advisable, because set color is a public method and it can be overridden. So it says overridable method call in constructor, which means you're doing something that maybe potentially can lead to a problem. So the best way is to, when you control whatever you do, you control how it is initialized. So this is how you control, you send it to your superclass. But the question, even if it was not mentioned, should I just try to guess and add it? Well, not really. Well, if you want to make it useful, or if you'd like to use it, you're going to be forced to do something about it. So it's like you have to do it in this case. But let's say if your question was, in an exam, should I be doing this kind of thing? So in an exam, I'm going to be more specific. I'm not going to be leaving you with a lot of options to do, because we're in the beginning of the semester. At the end, maybe I'm going to leave you more into trying to wonder, but in the beginning, we're just getting in. So now I'd like to do something which is the get area. So the public double get area. Now what's the formula for calculating the area of a triangle? So 0.5 multiplied by height by the base. So there's no real need for those parentheses, right? So I can just do something like this, or this divided by 2, which is basically the same thing.
All of them
Exactly. But if I do it this way, it's not a problem. Why? Because these two have the same level, same priority. So I'm going to start from the left to the right, which means I'm going to do this first, then I'm going to divide. So putting the parentheses or not is not going to change anything. But even mathematically, if you divide this by 2 and then you multiply it by this, that's the same thing. But that's another story, whatever. So, but let's say, just to make it clear and without confusing, and just to close some questions that are not necessarily related to this, this is the formula for a triangle. I can just Google that just to make sure. Triangle formula, array area formula, for example, and then you're going to get something really nice. So this is the height of the base, and then the base, and then divided by 2. So fine. Now one thing is that this is going to be yellow in NetBeans. Why? Because it's overriding something. It means that now you're not using the get area from the superclass. This get area from the superclass has been changed to the one that is used here. And it suggests you to just add this override. So you can make it clear that when you see this method, you clearly understand what you're doing. Actually, this method is actually overriding a method from your superclass. Now this is going to become more interesting when I'm going to insert the toString. Now the toString, I would like to initialize this double height to show this. This is a triangle, and this is the base, the height. I can also add the color. And let's put color. And this is going to be coming from the superclass. So I'm coming to the area. So, but let's just put the color first. Now I need to put super dot get color. Yes. But what if I don't put even super? I just put get. I have get color, because when I'm inheriting, it's like it's in my class. I just can use it immediately without the need to do the super. Sometimes the super can be used if there's confusion. If, for example, I have get area from here and get area from there, and I'd like to use the get area from the superclass, I'm going to use super.getArea. Then I still have access to it. But for this, I can just use get color, and it's going to be enough. And yes,
When we should add
I'm going to show you the example. Now, for example, let's say I would like to add this get area. So I'm going to also add the area as one of the things that I'm going to be displaying, and I'm going to use get area. Now, by doing this, what is going to be happening is that this get area is going to call which one? This one here. What if I don't want to call this one? I would like to call the other one. Exactly. Just use the super dot, and because there's a get area that is available, then this is okay. I can use that. So now, if I use this one, this is going to be 0 because that is how it is calculated. But if I use the one that is locally, well, it's going to do the multiplication of the base height divided by 2. You can, yes, it's still available. When you override a method, doesn't mean you cancel it, you cannot use it anymore. It's still there, but the one that you have is going to be the default one. If you would like to use the other one, you have to use super dot. Yes. Yes. With the get area? Depending what you would like to do. You would like to get the area, the formula for the shape, or the formula for the triangle. Which one you'd like to use?
from the shape.
If you'd like to use the one from the shape, then super dot, get area. But that's not the one I would like to use, because I'm in a triangle. I would like to use the formula for a triangle. So I will use the one that is going to be this one. Because the other one gives me always 0. This one I would like to see the result of the calculation. Now, just doing this, I'm having a problem here because the triangle now does not have only one argument. I mean, the constructor does not have one argument. It has 3 of them. So either now the options that I have, if you just remove this and the control space, it's going to show you what options do you have. You have an option to use triangle with just no arguments. And then if you'd like to set the height and base, whatever, you have to just to use this and t.set height to be 2, for example. If you'd like also to set the color, it's still available because, but it's not bold because it's not coming from your class triangle, it's coming from shape, but I still can use that, and then I can put any color that I want. Now this way I'm going to see that this is a triangle, that's the base is 5, the height is 2, the color is this, and the area is 5. Why? Because 5 multiplied by 2 divided by 2, that's fine. But this is not the best, I mean the most convenient one. The most convenient constructor is the one that has everything, so I can just in one line I can just put everything, and then that's much. Let's just change it so you can see that it's on the other one, and I can just get rid of all this line of code. In just 2 lines I can do the same thing that I did in 5, and that's the thing. This is still not polymorphism. There's no more polymorphism in here involved, because it's, well, this is just what we did before. Yeah, this exactly. Now let's just do something more interesting. I mean, we can just play with that thing now, but I just would like to have a rectangle. Now for the rectangle, I'm just going to speed up a little bit. Now you all know what is going to happen, so I'm going to make it private, double, length. Is it length? Length and width. Copy paste, and then width. Yes, true, I forgot, thank you. So I need to extend shape. Then I'm going to insert the constructors. One just initializes not everything, just empty, to have the empty one just for convenience, and then another one that is going to be doing a lot of the same thing that what we did with triangle, and then this is just done. Now let's just insert the setters and getters and make sure it's just in case I did not put them as private, but I know that I did, but just use it. It will not hurt if you add it. Now I just would like to have this to get area first, because the toString is using get area, so I'm just going to use this get area. I'm going to insert override method, and I'm going to select the get area from shape. So it gives me also if I'd like to override something that I'm inheriting from my superclass. So, but I don't want to do that. But I just would like to inherit. So to change this get area. So let's do it now. I just would like to, instead of now this one just tells you by default you can use the one from your superclass, but I don't want to do that. I just would like to return the area of by getting the length multiplied by the width, and that's it. Now the toString, I'm just going to copy this because it's much faster and paste it. Of course this is not a triangle, this is a rectangle, and there's no base, it's length and width, and the rest is the same. Now this get area is going to be the one that is from here. If I run, of course there's nothing because I'm still did not change it. Now what if I change now to this to be a rectangle, and if I change it to be a rectangle, if I run this, now this is going to be a rectangle of this length, and this is the area of a rectangle. Fine. Let's talk about in here, this polymorphism. I'm going to show you an example where this polymorphism is working, but this example now is requiring me to have a lot of shapes. So let's say I'm going to just have 5 different shapes, and I'd like to display the information about those shapes, 5 of them at a time. Of course, if I'd like to have all these shapes, I can just have this, and then have another one. Now this is the first shape 1, this is shape 2. Let's say I should have used refactor. This is one thing that I should have done. And now I have one triangle. Maybe let's add another rectangle. Now I'd like to have 5 shapes or some kind. Let me change the values a little bit just to put some changes. Of course this should be, now I'm going to use Control R, so it's going to be S3, and then let's make it red, and another one, and this is going to become S4, and this is white, and let's put it like this. Now I have these 4 shapes. I need another one. Let's just add another one, so to make them 5. Now notice that there's something that let's call it S5. Now if I only have these 5, this is still not really useful. Because what if I have 100? It's each one of them. I need to initialize it and do it. What if can I use this some kind of things of a loop? Yes, I can. There is a possibility. I can use this something like a loop to do that. But how can I make a loop to display these things? Well, let me show you. First of all, can I have these to be inside of an array? Can I have an array of triangles and rectangles? How can I have an array of, at the same time, and elements can be of different types? One thing that we said about arrays is that they are very convenient. They have many elements and they're one name, but it's one data type, right? If it's double, it stays double. Every element is double. So how can I have an element that is a triangle, another one that is a rectangle? That's something that is available with inheritance. I can create an array of shape. Now by making an array of shape, let's go at my list, for example, I go new shape, and I put 5. The first equal sign is not really helping. Now when I do something like this, because all the rectangles and triangles are subclasses of shape, I can this now, for example, this is a shape list of 0. The first element is a shape. but I can put a rectangle or a triangle into a shape, so I can do this. And this one is gone. It's possible to put a subclass, a subtype, into a supertype. That's what we've seen last week. It is possible to put something from a subclass into its superclass's type. And that's one of the good advantages, because a triangle is a shape. And a rectangle is a shape, because they all inherit from shape. That's the kind of relationship it is. This one is another one. So this rectangle is a shape, so I can put it into that data type. And that's a good thing. Now I have into one array of shapes many different types, actually subtypes. So I can have something like this, and then I can initialize each one of those with things like that. Are you still okay with that? What I'm going to do a copy paste. So this is 2, 3, and 4, and that's it, because I said 5, so from 0 to 4. Now what I'm going to do, just going to cut these and paste them paste them here. Or maybe just this thing. Okay. And then the last one is this one. And this is still not polymorphism, even though it takes many forms, but that's not.
Still the same question, though. What if we had 100?
If you had 100,
You will have
but you can initialize them in some kind of a loop that is going to take some values from the user, for example, or from some different places, a file, if we need to. Yes.
If you want the same type of information, you can make it with the loop, so the number inside the list can be added more.
I mean, the initialization part, I don't want to focus on it too much, because it's much more complicated to make it into a loop. But what if I would like to display once I have them initialized, let's say? If I'd like to display them, it's much easier for me to put that in a loop, like now, like this, list dot length, and then all I need to do is list I. Now this is going to display all of them one by one, which basically what I'm doing, I'm just calling the toString, right? The toString, that's what I'm calling. Dot toString. This is basically the same thing as this, right? And now this toString, sometimes it belongs to the triangle, sometimes it belongs to the rectangle. But notice something, we never see toString of the shape. Now let me ask you something, and this is polymorphism. Now toString is taking many forms, because now toString, if you just look at it this way from just the compiler perspective, what is the data type of list I? It's shape. toString should be coming from shape, but it's not. Now toStrings have different forms based on the subclasses that they were declared in. Now even though this is called shape, when I put a triangle into a shape, it remembers that it is a triangle inside of a shape. When I put a rectangle inside of a shape, it just keeps that information. It's a rectangle inside of a shape. I don't lose that information. So when I call a method toString, now this toString takes many forms, because one method name, one call, is the same name, the same instruction, which is going to give you different results. What is it? There. Now that same instruction is sometimes going to be using some statement from a class, and sometimes from statements from another class. Now the code that gave me this is different from the one that gave me this, but it's the same name of the method, it's the same call. So toString now is polymorphic, which means it has many forms, it takes many forms. And this is done with something that is called late binding. Late binding, what does it mean? It means now that Java, what it does when it runs it's also called dynamic binding, late binding, dynamic binding. You just need to remember that one because it's important. So it's called late binding or dynamic binding, the same thing. What does this mean? When it runs, Java is going to look at this list I. It's a shape, it knows it's a shape, but it will know, is it inside of it a shape as well? No, it's not. Well, what is inside of it? Is it the triangle? Okay, let's go now let's connect this toString to the one that is in triangle. So if you just look at it this way, it might seem that toString belongs to list that belongs to a shape, but it's not. toString is going to be attached to, depending either it's a triangle or a rectangle, and if I have many subclasses, square, circle, it's going to be the same idea. The link is going to be done at runtime. That's the polymorphism, and it relies on this late binding. Yes?
So if we do some changes into string on rectangle or triangle,
Yes.
it will copy the changes and then
Of course, yes. Of course. Let me just show you, for example, maybe instead of doing this whole toString, I have another method that is also there, which is getArea. Now getArea now, if you just look at it this way, I'm getting an area of a shape. Because what is the data type of list? Again, it's a shape. It's many elements of shape. So normally I should see a lot of zeros. But I'm not going to see zeros because what happens is that it's going to run for the first element. It's a shape. Okay, but what is really inside of it? Is the shape or another type? It's going to say, oh, this is a rectangle or a triangle. Let's now call the method getArea that is available in the triangle or in the rectangle. It will show you different types of area. Let me just show you another thing. I just forgot. Maybe let me show you another example with I'm putting 3 different types into this array, just so you can see different formulas getting used for each one of them. So the first one here, this is 5 because I'm using a triangle, so the area of the triangle. The next one, it's 10 because it's the area of the array. So the formula has changed. I'm not using the same method now. Now this red here is 0 because it's a shape, and the shape getArea gives you 0. And then you have this rectangle that's 22 multiplied by 1, and this one is 50 multiplied by 2 divided by 2. So now this getArea is taking many forms. So that's polymorphism. But it takes many forms because of this late binding or dynamic binding, which means now when you see this, if somebody just don't pay attention, it just, oh, what is the data type of list? Oh, this is shape. Okay, so this is going to be the formula used from this getArea from the shape. No. It depends on what's inside of that shape. If it's a subclass, and it's going to be looking at the one that is available in that subclass. But of course, there's some kind of preconditions. You cannot do something like this if you don't have inheritance, because you cannot put something like, for example, like this. Well, let's say, why can't I do that? Because its object is the superclass of the shape, not its subclass. So you cannot put something in opposite way. Or if I have, remember the scanner, it has nothing to do with shape. If I have the scanner, let me just use scanner. If you remember system.in, of course it's going to complain I don't have scanner. Let's import it, no problem, just import it. Now I have this, but still I cannot put a scanner into a shape. There's no relationship between them. But if it was a subclass of it, then yes, it's possible. So one of the preconditions for this polymorphism to work, this late binding or dynamic binding, it has to be some kind of inheritance, and that's not enough. The other thing is that I need to have this method getArea available in all classes. So I have all these ones that are involved. They have this getArea. Sorry, this is the one, and also this one, because if I remove this one, now this is not a, this is a problem because I'm saying overriding, but it's not really overriding. I can fix it by just removing this, no problems. So now this triangle is okay. The rectangle is now okay if I remove the same thing. Now what is the problem with the shape? It's going to get area, but there's no get area. That's why the problem. I'm just going to remove it and put 0 just inside of it, for example, just like this. Now I'm fixing everything except this one. Now it will tell you, hold on, you cannot call get area, even if get area is available in the subclasses, but the superclass doesn't have it. And you say list I dot, what is available in list I dot is only what's available in the class, not what is available in the class and the superclass. So it's just what's available in the class. So you cannot have access to the subclasses, and that's why if you would like to use something like this, some polymorphism, this method has to be available in the superclass and all its on the other subclasses. Yes.
If we don't have the method here to get area in one of the subclasses, can I call it?
No, you can't. It's going to be a problem. Now that's a good point. But now let's say we understood that if I'd like to have this get area to be polymorphic, I need it to be here. That's why, even though this doesn't make a lot of sense to have a get area of a shape because there's no formula, but we have to put it because it's needed to be used in that way by the other classes. Now your question is, which is a good one, what if I don't have get area in one of those? And then I'm just going to be, let's put whatever, I'll just put here for the triangle because there's no get area. Now is it going to be a problem? No. But when I run, is it going to be a problem? No, because it's going to take the one that is available from the shape. So if I run this thing, well, this is going to give me the one from the shape. So the one from the shape gives you 0, so fine, I have one, I have something. That's why if you don't have it, you cannot use it. That's the problem. So
But it will be called also polymorphism.
yes, of course, it is going to be called polymorphic, yes. Because get area changes with calls, depending on calls. I'm going to put -1 just to see that actually these are like the one that's just -1. And if I make the triangle not having, where's the triangle? Not having this get area, and I can use this, keep it like that, because get area now is going to give me the one coming from the superclass. Now you see, I have this -1 every time there's a triangle. Let me fix this. So every time there's a triangle or a shape, is going to be -1 because there's no get area inside the triangle. And that is polymorphism. So polymorphism requires a lot of things. First of all, inheritance. There's no inheritance, no polymorphism. And polymorphism is like the method get area is polymorphic because it takes many forms, but it relies on this kind of late binding because this attachment of a method to which object is done at runtime. It's dynamic. That's why it's called late binding, dynamic binding. So it changes, and it's done at runtime. And also it needs this overriding, so you can be able to use it in that way. So to use it this way, like for example. Yes.
The two subclasses have the same kinds of variables.
Variables?
Recognize the subclass.
I don't get your question because variables are known only locally in the class, so it will not be a problem if they are the same.
And the rectangle have in the constructor have base and height.
Okay, let's say in rectangle you'd like to call them also base and height. That's your name, or keep these and add another one.
No, I mean make both subclasses have the same name variables. I mean,
Okay, tell me what to change here, for example. What do you want me to change? In triangle?
I want them to have the same names.
Just tell me what to do. Because I'm not sure to understand your question. That's what I'm telling you. What do you want me to change?
The two classes have the same name of the instance variable.
The two classes have the same name of instance, like these ones, right?
Length and width.
Okay. Now, is it going to be a problem? That's the question, right? No. Now I'm going to rename that to base, and this one to length. What? Height. Because this is not going to be a problem. Why? Because these are only known inside those brackets, those braces they're declared on. So which means it's only known inside the class rectangle. And the way you work with it, now I'm calling them base and height, but actually I'm using them as width and height, and there's width and length. It doesn't matter, because in my formula, you see, I'm just multiplying them as if the names are different. So the names are not really necessarily important. They're just important for us, not for the computer. Because for the computer, what's important is what should I do with it? What should I do with those variables?
And how to recognize how it knows what to use.
Because now, can it use something else?
Which string to use?
With toString?
Yes.
Well,
There are two strings in the subclass.
which ones? The only one in the subclass. In this one, there's only one toString.
Yes, and in triangular we have two strings also.
Or in the other class. Now the same thing now happens with this. Which one is going to be used if I use getArea? Which one is it going to be used? Because I have one in triangle and one in rectangle. So it's the same idea. It just looks at what's inside. This is list I, let's say list 0. When 0, what's inside is triangle. So I'm going to use the one that is coming from triangle. And let's say now I is 1. What's inside of that? Is it a shape or a rectangle? No, it's a rectangle. Okay, I'm going to use now the one that is coming from the rectangle. And this is how it is going to be distinguishing between the others. Yes?
Why delete the area?
28.
Yeah.
This one.
Yeah. You will show to me the constructor.
No, this one is going to show you the toString.
The complete toString.
Yes. It's like doing this.
Yeah, but the shape
Does have a toString. Yeah, because we did have like this one. But let's say I don't have it. But if I didn't have that toString, now what I'm going to see is that the default,
yeah, because of the
because I have one that is coming from the object. Yes.
Can I see the main? Yeah. What if rectangle was a subclass of triangle before?
What if rectangle was a subclass
Triangle.
of triangle? So instead of
extends
extends from shape, extends from triangle.
The main will be correct.
Well, first of all, it's
a lot of changes.
I need to just I cannot do this. Let's say I need to update the ones on my subclass. So this but I'm going to call let me no, I'm just going to keep it and then do something like this, because there's a constructor in my subclass, the triangle, that takes 3, the base and height and color. So I'm just going to take everything from there. But now, if I run this code now with the toString or with the whatever, so if I run this code, the first time this is going to be a triangle. So I'm going to get the triangle, the getArea from the triangle. Now, if I use the rectangle, the toString, which one is going to be used? The one from the triangle?
The one from the
Because what is what's inside of this list 1? It's a rectangle. So I'm going to use the one that is from the rectangle if it's available. If it wasn't available, the question would have been, what if I don't have toString inside the rectangle?
check the one.
It will take the one that is available from, no, because this is inherited from triangle, and triangle has toString. I'm going to use the one that is immediately available, which is the one from toString. So this is going to be a messed up thing to see, a lot of triangles. But I hope you did not confuse yourself, because there's a lot of things that are coming from this triangle. But the idea is that it's looking for, no. Oh, yes. Yes.
No, so we run the shape. We can't have the shape.
Because I removed from the shape the toString. Because I removed the toString from the shape, so it's just using the toString that is by default coming.
Okay, that superclass takes something from the subclass of it, that is subclass.
No, this is not. This is the opposite. This is now this thing this toString from here
Yes.
is looking for toString in shape, but it doesn't see shape.
Yes, I know.
So it goes into its
Yeah.
upper class, superclass, so it finds the toString there. So this is not like a class that is looking at its subclasses. So every time it's the same class looking at what's inside of itself or its
No,
parents.
I mean, when you create the array now, in the first place it was a superclass and it's subclasses.
Which one? I didn't.
Shape.
Okay, this shape. Okay,
No, the shape.
this one.
Yes, list.
Okay.
When we created it, it was a superclass and it's a subclass.
No, it's just the superclass.
Superclass.
There's no subclasses there. This is just what I said is that this is a shape. I have 5 elements that can be of type shape. Now, what you put in them, what you're allowed to, is any shape or its subclasses. So this is what we're doing here. Now here I'm doing, okay, put a triangle, then put a rectangle, then put a shape, I don't know what it's represented, and then put another triangle or rectangle, I don't remember, rectangle, and then put a triangle. This is possible because of the relationship subclass superclass, but not because of the way it is. Because it doesn't mean that when I do this, I always have access. I have access to my subclasses. I'm just allowing my subclasses to be put into my space. That's what it means. Yes, somebody? Yeah.
So we have the same situation. Then the superclass is the shape,
Yes.
and the triangle and the rectangle are the subclass.
Subclasses.
And the list is a list of triangles.
List of triangles. Okay, if I do list of triangles, that's a good try. Okay, what happens if I do list of triangle? Triangle, yes. Now if I have a list of triangle, nothing will work except triangle and its subclasses.
So we can't use shape in a list of triangles.
You cannot use something on super. You can always, it accepts, if you are a data type of a class, if you're an object of a data type, you can only accept your own data type and your kids, not your parents. Yes.
If the extent, the inheritance from triangle and rectangle.
Exactly. Now, if we kept that rectangle is inheriting from triangle, then all the rectangles are going to be okay, but not the shape. Yes. Yes.
If we want to find the max area between all of them,
The maximum between all of them.
the max area, this is the area.
The max of the area. Yes.
How can we do that?
Okay. Well, thank you for giving me this Java 1 task to do. Okay. Well, first thing, you just, let's say, declare a variable that is max. And what I would do, I would just put max is to be list 0 of get area. So I get the first one and assume that this is a max. And then I'm going to start from 0 again. From 1 until the end, what I'm going to do, if this max is smaller than list of I dot get area, which means the get area of that next element is bigger than this one, I'm going to make it max is equal to this one. Sorry. And then at the end, I'm going to display the maximum area is sorry, just max. Okay.
Just the difference is just dot get area.
Yes. But that's a good example because this is still polymorphism, because this get area is going to be a get area of a rectangle, of a shape, of a triangle.
And in this situation, that will give me the max of the three constructor here, or only one?
No constructor. There's no constructor there.
I mean the shape, rectangular.
Yes, it gives me the maximum of the area of these three, these different shapes. I have 5 shapes. I have 5 different shapes. So a lot of fun, right? You can't wait to see those, how this